You're looking at one of the most underrated products in the world of computing. A computer so small, it fits in the palm of your hand, yet powerful enough to run Windows 11, handle 4K video, and replace your desktop. But here's the real question nobody asks. How is this tiny machine actually made? Today, we're going inside one of China's leading mini PC factories, Beelink, known in Chinese as Lingqi, to follow every single step of production, from a flat sheet of aluminum all the way to a boxed, tested computer ready to ship. Let's go. This is Beelink's headquarters and production facility in Shenzhen, China, one of the world's most concentrated electronics manufacturing zones. Inside, hundreds of workers operate across multiple production floors, each dedicated to a specific stage of building a mini PC. What you're about to see is the complete journey, step by step. Every mini PC starts not as a circuit board, but as a flat sheet of aluminum. Here in the stamping department, massive industrial presses from Yadon and CIE, some generating over 60 tons of force, punch and shape these sheets with extraordinary precision. Before each piece enters the press, workers apply a light coat of oil. This prevents the metal from cracking during the high-pressure forming process. The first operation is called deep drawing. You can see the Chinese characters La Shen written right on the press die. The flat aluminum disc is pushed down by a punch into a die cavity, forming the iconic rounded square shell of the mini PC. Once the basic shell shape is stamped, it's far from finished. The shell still needs all of its precise features. The USB ports, HDMI openings, ventilation holes, mounting points, and the perfectly smooth exterior surface. That's where CNC machining comes in, computer numerical control milling. The shells are clamped into precision fixtures, and high-speed milling cutters carve out every detail. Notice the coolant fluid flooding the work zone. It removes heat and flushes away chips to keep the cutter sharp. The result? A shell with perfect port openings, crisp edges, and a smooth matte surface ready for finishing. CNC machining is precise, but it can leave tiny burrs and tool marks. The next step is manual finishing. Using pneumatic orbital sanders, spinning at thousands of RPM. Workers carefully smooth every surface. The front I/O panel you see here already has its port openings cut in. The worker sands the exterior sidewalls to remove any marks left by the CNC process. This is still a raw aluminum surface. No color, no coating. That comes next. But first, the shell must be inspected. At the quality inspection station, every shell is checked for dimensional accuracy, surface defects, and port alignment. Anything outside spec is pulled before the expensive finishing stages begin. Now, the shells go through one of the most visually dramatic stages, chemical surface treatment. First, the shells are loaded onto special racks. These aren't just holders. They're electrically conductive jigs, because the main process here is anodizing, an electrochemical treatment that converts the outer layer of aluminum into a hard, corrosion-resistant aluminum oxide coating. Before anodizing, the shells go through a series of chemical pre-treatment baths. Degreasing removes oils and fingerprints. Acid etching creates a uniform matte surface. Neutralizing baths clean off the etch chemicals. Then comes the actual anodizing tank. You can see the dramatic moment right here. Electric sparks fly in the liquid as electrical current flows through the parts. This is the anodic oxidation process actively forming the protective oxide layer. After anodizing, a dye is applied. It seeps into the porous oxide layer, creating the silver or dark color characteristic of Beelink products. Then a sealing bath locks the color in permanently. While the aluminum chassis goes through metal treatment, the plastic components, like this white top cover with the Beelink logo, go through a separate paint and coating line. Automated spray painting robots apply a consistent, even coat of paint to every surface. The robotic path is programmed precisely so no area gets too much or too little coverage. This is what gives the Beelink its signature clean white finish. One detail most people never see. A precise bead of blue thermal and acoustic sealant is dispensed robotically around the I/O frame. This seals the joint between the plastic front frame and the aluminum body, preventing vibration and keeping dust out. This is where the real magic happens. Welcome to the SMT floor. SMT stands for Surface Mount Technology. This is where the motherboard of the mini PC is built. This is the bare PCB, the printed circuit board, model SER8V13. At this stage, it's just copper traces and solder pads on a fiberglass substrate. No components, no chips, just an empty board waiting to come to life. The first step is solder paste printing. A metal stencil, with holes cut exactly where each component will sit, is placed over the board. A squeegee pushes solder paste through the holes. The result is tiny dots of paste on every pad. Next, the board enters the pick-and-place machine. Cameras locate every component reel. Robotic vacuum nozzles pick up parts, capacitors, resistors, chips, at speeds exceeding 50,000 placements per hour, and set them down on the solder paste with sub-millimeter accuracy. These Panasonic NPM machines are some of the best in the world. Every green light you see means a machine is running perfectly. After pick and place, the board goes through a reflow oven, carefully heated to melt the solder paste and permanently bond every component. What comes out is a fully assembled motherboard. And right here, you can see the heart of this mini PC, an AMD Ryzen processor. This is what gives the SER8 its punch. Radeon integrated graphics, DDR5 RAM slots, 2 M2 NVMe SSD slots, a Wi-Fi card slot, everything a desktop needs, in a board barely larger than your smartphone. Before a single screw goes into the chassis, the motherboard must pass a full functional test, completely bare. Every port is connected, power is applied, the unit boots Windows 11. A custom test script automatically runs through every hardware function. CPU detection confirms AMD Ryzen 7 8845HS. Storage shows the NVMe SSD. Graphics shows Radeon 780M. MAC address is verified. Network speed is checked. And the audio test, which you can see launching here, checks both speaker and microphone paths. Any board that fails is flagged and sent to the rework station. Only boards that pass every test move forward. Heat is the enemy of electronics, and managing heat in a device this small is one of the biggest engineering challenges in mini PC design. First, thermal paste is applied directly to the processor die, that small square chip you see here. The paste fills microscopic gaps between the chip surface and the heatsink, allowing heat to transfer efficiently. Next, a copper heatsink is installed. Copper transfers heat nearly 3 times more efficiently than aluminum. The fin array provides enormous surface area for heat dissipation. Thermal pads also touch the RAM and other components, drawing heat away from multiple sources at once. A centrifugal blower fan, similar in design to a laptop fan, sits beside the heatsink and pulls cool air through the fin array. The fan is connected via a small subboard that also carries the power button. This is the moment everything comes together. The tested and approved motherboard, with its heatsink, fan, and all components, is carefully lowered into the polished aluminum chassis. Looking inside the fully assembled unit, you can see the engineering density. Motherboard, heatsink, fan, NVMe SSD, Wi-Fi card. Every centimeter of space is used. The Wi-Fi card is a standard M2 form factor Intel module, meaning any customer could swap it for a newer generation card in the future. The antenna cables that run up to the chassis walls maximize wireless range despite the metal enclosure. The bottom panel, with its array of ventilation holes for airflow, is then secured with precision screws. The unit is sealed. Now comes the most important stage of all, the burn-in test. Every assembled unit is powered on and run continuously for an extended period under load. You can see the voltage and current meters on each unit. Any anomaly in power draw immediately flags a problem. Alongside the burn-in, workers perform a full system functional test on each assembled unit, including speaker output, microphone detection, USB port detection, display output, and network connectivity. Only when every test passes does the unit move to the final line. Watch the units glide along the production conveyor, each one a completed, tested mini PC, heading toward the final inspection and packaging stations. Final visual inspection. Every unit is checked by hand. Exterior surfaces, port alignment, labels, and overall appearance. Any cosmetic issue is caught here. The unit is cleaned and the final regulatory compliance label is applied. CE for Europe, FCC for the United States, UK CA for the UK. This label is your guarantee that the device has met international safety and electromagnetic standards. Weight check. The scale reads 794 grams for the bare unit. This isn't just a quality check. The weight data is fed into the system to verify that the complete unit, once boxed, matches the expected package weight. A unit that's too light might be missing an accessory. Too heavy could mean something is wrong. On the packaging line, the unit is placed into its retail box alongside the power adapter, HDMI cable, user manual, and quick start guide. The sealed box is then weighed one final time to verify all contents are present. Then the box is scanned, recorded, and moved to the shipping warehouse. From a flat sheet of aluminum to a stamped shell, through CNC machining, anodizing, painting, PCB assembly, soldering, testing, more testing, assembly, and packaging. This tiny computer passed through more than 50 individual production steps and the hands of hundreds of workers before it ever reached your desk. That's the real picture. If you found this video interesting, drop a like and subscribe to The Real Picture for more factory deep dives. We go where the cameras usually don't go. See you in the next one.